Welcome back from the ad break, and let's continue with our lesson. So now we are still squaring those brackets. We have here number 7 that says 1/3 minus y, and that's in brackets, and then we are squaring that bracket. So let us start off by writing the bracket twice. So that is 1/3 minus y, 1/3 minus y. So we are going to multiply the way we should. So it's the first ones first. 1/3 multiplied by 1/3 is 1/9. Then we are subtracting. Then we have 1/3 multiplied by y. This is going to be 1/3 y. And then we have y multiplied by 1/3. That is going to be 1/3 y. And then we are subtracting, but because in both brackets we are subtracting, remember, subtracting a negative gives us a positive. So now we have y multiplied by y, that is a y squared. How are we going to simplify this? Firstly, let's write it in the correct order, that is y squared. Then we look for the like terms, and the like terms in this case is 1/3 y and 1/3 y. So minus 1/3 y minus 1/3 y. What does that give us? That gives us a minus 2/3 y. And then plus the 1/9. And that's our answer for that expression. Let's move on to the next one. We have there x minus 3, and it is also squared. So we are just going to write it out twice and multiply. What is x multiplied by x? That is x squared. We are subtracting. Then we have x multiplied by 3. That is 3x. We are still subtracting from that bracket. That is 3 multiplied by x. That is 3x. And then finally, we are still subtracting, and because in both brackets we are subtracting, it will become a positive. Then 9 multiplied by 9, I'm already giving you the answer. 3 multiplied by 3 is a 9. Let's simplify that. Do we have any like terms here? Yes, we do. The 3x and the 3x. So we are going to say x squared. Then what is minus 3x minus 3x? That is a minus 6x plus the 9. And that's our final answer for that. Let's go on to more application questions. So we're still simplifying, but now we are going to apply everything that we've learned now into more expressions. Let's look at this first one. We have two binomials as a numerator, and as a denominator we have a constant. So that 2 is a divisor for each of those binomials. What we are going to first do is to multiply those binomials and get one expression. So that is going to be 2 multiplied by x, and that gives us 2x squared. Then we have 2 multiplied by 6, because we are adding, that will give us a 12x. Then we are subtracting 4 multiplied by x, that is 4x. And then we are still subtracting 4 multiplied by 6 is 24. Now all of this is divided by 2. So we need to simplify it. And how do we simplify? Identify the like terms. Which ones are the like terms? Yes, it is the 4 and the 12. So we are going to simplify that. That is going to be now 2x squared. 12 minus 4 is an 8. So that has been simplified to 8x minus 24, and all of these are divided by 2. Do you remember how we divided trinomial with a constant? Each of the terms in that trinomial is going to be divided by the denominator or the divisor. So we are going to have 2x squared divided by 2 plus 8x divided by 2 minus 24 divided by 2. And the answer that we're going to get from that, now 2 divided by 2 is 1, so we are left with x squared. 8 divided by 2 is 4, so we are left with 4x. And 24 divided by 2 is 12. And that is our final answer for that one. This next one, again, we are going to first multiply before we can divide with the divisor. So what is 4 multiplied by 8? That is 32. And we are multiplying the same base, so we are going to add the exponents. So that is going to give us p exponent 5. Then we have 4 multiplied by 6. We are adding that. That is going to be 24. Again, the p and the p, the same base, so we add the exponents. So that's going to be 24p exponent 4. Then we are going to subtract the 4 multiplied by the 8. That is going to be 32p squared, because the 4 doesn't have any variables, so we're going to take the variables from 8p squared as they are. Then we are still subtracting the 4 with the 6, and that is going to be a 24p. Now remember, all of this is divided by the 4p. Now if we look there are no like terms. But now we are going to take this whole polynomial and we are going to divide it by 4p. What is that going to look like? So we are going to say there 32p exponent 5. Okay, let me create more space here just to make sure we don't run out of space. So let's continue that expression there. We are going to say now 32p exponent 5 divided by 4p plus 24p exponent 4 divided by 4p minus 32p squared divided by 4p minus 24p divided by 4p. So each of those terms are going to divide by the 4. So what is going to be the final answer? We are going to say 32 divided by 4, that is 8. And p exponent 5 divided by p exponent 1. Remember, when we divide, we subtract the exponents. That's going to be p exponent 4. Then we have 24 divided by 4, that is 6. P 4 minus 1 is 3. Why are we subtracting? Because we are dividing. Minus 32 divided by 4, that is 8. And then p, we have 2 minus 1, that is just the 1p. And lastly, we have 24p divided by 4p. So 24 divided by 4 is 6. And then p divided by p is 1. So that is our final expression, and it has been placed properly in descending order of powers. Let's move on to more application questions. Let's look more at substitution. So we've been given an expression there, and we are told that x is equals to 10, y is equals to 5, and z is equals to 2. So we are just going to use our brackets to substitute those given values. Now we are told that x is equals to 10, and we are told that y is equals to 5. And we are also told that, sorry, that is a mistake. I was supposed to put brackets there. We are told that, all right. We are told that x is equals to 10, right? We are told that z is equals to 2. And we are told that y is equals to 5. That's the correct one. So let's calculate that. 10 minus 2, that is 8. And then when we add 5, we get an answer of 13. So let's not forget our equal sign there, and then our answer is 13. So let's move on to the next one. Now the next one, when we look at it, we can substitute the values that we are given, but we can simplify this expression first because there are like terms here. Which ones are the like terms? We have 10 and 4. So 10y and 4y are like terms. We also have 3x and 3x, so we can add those as well. So what is 10 plus 4? That is going to give us 14y. And then what is a minus 3 plus 3? That actually gives us 0x. And then we are left with a 5z. Now we can substitute properly. That is 14, open bracket. What is the value for y? That is a 5, right? And then we are minusing a 5, and we open a bracket there. What is the value for the z? That is the 2. Then we can go and we calculate that. What is 14 multiplied by 5? That is going to give us 70 minus, and then 5 multiplied by 2, that is a 10. And then what is 70 minus 10? That gives us a 60. And that's our answer for that expression. Let's simplify the ones here at the bottom. It's just 2 expressions that are being added. So that is our 7x squared plus 3x plus 5. And we are adding the 2x squared. We are also adding a minus x, but that is the same as subtracting that x. And we are also adding a minus 2. That is the same as subtracting that 2. So now we're going to look for the like terms. So when we look for the like terms there, can you identify any like terms? We have the 7 and the 2. So what is 7 plus 2? That is a 9x squared. Next, we have the 3x and the 1x. So we are going to say there 3 minus 1, that is a 2x. And then lastly, we have the 5 and the 2. So what is 5 minus 2? That is a positive 3. And that is the simplified expression of that one. Here's another expression here, which is 2p squared minus 5p minus 9. And then we are subtracting 5p squared minus 2p minus 1. So 2p squared minus 5p minus 9. We are subtracting a positive, so that is the same as subtracting it, which is 5p squared. Then again, we are subtracting a negative number. Now that is the same as adding it, so we are going to be adding the 2p, and again we are subtracting a negative number, so that is the same as adding that 1. Now, are we going to look for the like terms? Let's look for the like terms. We have there 2p squared and 5p squared. So we are going to say 2 minus 5. So what is 2p squared minus 5p squared? That is a negative 3p squared. Then we have the 5p and the 2p. So that is a minus 5p plus 2p gives us a minus 3p. And lastly, we have there the 9 and the 1. So a minus 9 plus 1 is a minus 8. And the final answer there is negative 3p squared minus 3p minus 8. Let's quickly go to an ad break and then we'll see you just now.